Welcome, my student. I am very happy to meet you in a new lecture. Today, we will talk about the parallel plate capacitors now we can ask you some question. What is the parallel plate capacitors meaning? The parallel plate capacitors meaning this is the simplest and the most commonly used form of capacitors it consists of two conductive plates. Two conductive plates, an identical plane, isolated and parallel. The area of each is letter capital A. These plates are separated by distance small d and equally but difference or oppositely charged. We can write difference or oppositely charged. That meaning in one plate it has a positive charge and the other plate it has negative charge. Now we can ask it you the second question. How do you charge an electric capacitors. How can you charge and capacitors and any capacitors? Now we are drawing the first plate of the parallel plate capacitors. The first plate connect to the positive pole of the battery or any source. Now we're drawing the second plate, and the second or the other plate connecting to the negative pole of the battery or any source. The source in this figure, battery or electric battery. The first plate will be charged with positive charge. Charge as a result of the transfer of negative charge from the plate to the positive pole of the battery due to the attractive force of Coulomb's law. The other plate will be charged with a negative charge as a result of the transfer of negative charge from the battery to the plate. The first we can obtain the first plate is the positive charge, and the second plate is negative charge. We obtain the two plate. One plate is charged by the positive charge, and the second plate is negative charge. After we have obtained a positive plate and a negative plate, a regular electric field will be formed whose field lines will emit from the positive charge to the negative plate. One positive plate to the negative plate. Now we can ask it you from the figure, what's the net total charge on the two plate or on the two parallel plate capacitor? We can answer for this question from the figure. The one plate, it has positive charge, and the negative, the other plate is has a negative charge. The total charge equals 0 because both plates have equal and opposite charge or different charges. That meaning the one plate, it has charge equality for the second plate charge. Finally, the total charge in this case equals 0 because both plates have equal and different charges. We can obtain the total charge equals 0. This is the one question from the ministry questions. We can ask it equal the net total charge equals 0. Now we can ask it you another question is very important. One question from the most ministry questions or very important ministry questions. When is the electric field generated between the two parallel plates of an electric capacitors uniform. When the electric field generated between the parallel plate of an electric capacitors uniform, we can answer for this question. The electric field is considered as a uniform if the distance, the electric field is considered as a uniform if the distance small d between the plates is very small compared to the dimension of the plate, and irregularity of electric field lines is very small compared to the dimension of a plate, and irregularity of electric field lines at the edge is ignored. We can ignore the field lines on the edge of the parallel plate capacitors, because not uniform in the end of edge of the capacitors. Therefore, we can ignore these lines at the edge of the capacitors. We can, from the figure, we can see the uniform electric field and ignore the electric field to the edge of the capacitors. Now we reach the end of this lecture. I hope to meet you in a new lecture, and thank you and goodbye, my student. Thank you very much.